Hello, everyone. Welcome to this session on Arm-based Microsoft Azure virtual machines. My name is Bhumik Patel, part of the software ecosystem team within Arm's infrastructure group. And I look forward to spending the next few minutes sharing our efforts with Azure team on the Arm-based VMs. As a quick introduction, at Arm, we are a global leader in semiconductor designs, and our IP designs and software platforms are deployed widely across various different segments. We have 250 plus billion Arm-based chips shipped to date, and this really spans across client computing, smartphones, IoT and embedded edge, all the way to the data centers and cloud, which is what we'll focus on today. Together with more than 1,000 plus our partners, we are really defining the future of computing. These are the trends driving computing infrastructure in the cloud. Data explosion and AI workloads driving tremendous scale and growth. Sustainability requirements are increasingly important as infrastructure plays a key role. And Moore's law not allowing off-the-shelf compute to keep up with the performance requirements. This is where we introduced Arm Neoverse a few years ago. It's a family of CPU IP designs that powers the next-gen cloud infrastructure. The value proposition of Arm Neoverse is simple: providing improved performance on a broad set of workloads with VMs per CPU metrics best in the industry. With the reduced cost, Neoverse-based instances are priced lower at the same amount in the cloud offerings. And last but not least, they provide boost in your sustainability goals and carbon footprints. If you look at the Neoverse portfolio, we've delivered 6 Neoverse CPU cores since 2018. These cores are across different families where we balance both power and performance envelopes to meet the needs of various infrastructure deployments. And we are leading industry in providing the performance per watt metrics and providing increasingly better performance for a wide variety of workloads. Now let's take a look at the Arm-based Microsoft Azure VMs. Microsoft announced this last year. These are powered by Ampere Altra CPUs that are really both for general purpose and memory intensive workloads. So if you look at the DP-SV5 family, they can run generic Linux workloads, cloud native workloads, application servers, your CI/CD loops. Broadly speaking, it can run a variety of workloads. The E series is more memory intensive and tailored towards in-memory caching and database applications. All these VMs are available on Azure, and it comes with the increasing support of the software ecosystem. Microsoft also announced the burstable virtual machines, which really is meant for use cases for applications that do not need the full performance of the CPU all the time. So we at Arm tested this use case and showcased a CI/CD lifecycle of a Spring Boot-based web application using GitHub Actions. So when your CI/CD running on a burstable VM is performing below baseline, it's accruing credits, and then it can burst when needed up to 100% of the CPU utilization. So this is really providing cost savings at a performance that works for developers. Now let's look at the software ecosystem. So at Arm, we've been working hard over the years to make sure that the broad software ecosystem support is enabled for you to deploy these instances from day one, right? So if you look at all the major operating systems that are supported today, we really drive this with the ecosystem through our program called Arm System Ready. So this enables all the OSs to boot and be day one ready. And beyond the operating systems, there is really mature support for the Arm software ecosystem across the board. We've been working over the years to get commercial ISVs support Arm, and hundreds of ISVs and open source projects natively support the Arm architecture. And thanks to cloud leaders like Microsoft, we are really able to drive this through deployments in the cloud. Now, let me cover some key software deployment best practices. So first, like we mentioned, all the Linux OSs support Arm, and our partners provide these distributions with precompiled Arm libraries for you to leverage. When it comes to languages and library support, we really recommend you to use the latest available versions out there and leverage the pre-built optimizations we've done. For example, Arm and Microsoft teams have worked very closely on providing performance improvements in .NET 7 and 8. And these best practices are publicly available. For your cloud native workloads, you can leverage multi-architecture builds with Docker, using the Docker build X commands. And you could really build your hybrid Kubernetes clusters using both x86 and ARM nodes. So you can manage this in a hybrid manner. And of course, we get support from the native Kubernetes service, Azure Kubernetes, AKS, that we'll talk a little bit about as well. We have support from CI/CD partners that let you build code natively on the ARM architecture, which gives you the performance in your development pipelines, whether it's Canary style or blue-green deployments, including support from Azure pipelines on ARM64. Once you get your toolchain in place, the next step is to do performance profiling on your application, right? We recommend you leverage open source performance tools such as perf and UBPF, and then really establish baseline in your environments, right? There are a lot of best practices to leverage here, which we provided on developer.arm.com, and really specific tunings that are done for different workloads that you could leverage. And last but not least, if you are a developer and you're looking for, setting up your infrastructure, there's scripts and infrastructure as a code tools available that you can leverage, and also programs such as Works on ARM that provide you access to free instances, including in Azure or physical platforms that you need to do your development. Now let's take a look at an example of building a multi-arc application using Azure Kubernetes Service. So in this brief walkthrough, you have an existing x86-based application running in your cluster, and now you're looking to add an ARM-based node pool to your cluster, right? So you could choose one of those D-series or E-series VMs that we saw earlier, and you could create a hybrid AKS cluster by adding these ARM-based nodes to the cluster. Once you do that, the next step is to add a node taint, which lets the Kubernetes scheduler know that a particular node is designated for one architecture only. This level of toleration lets you designate pools that can be used on tainted nodes. And in a hybrid cluster setup with nodes from different architectures, adding a taint on the nodes avoid the possibility of scheduling pods on an invalid architecture. Next, you could create a multi-architecture Docker file by following language-specific recommendations, and then build a multi-arc Docker image and push it to your Azure Container Registry. Once you do that, you deploy this multi-arc application image on the hybrid AKS cluster with both x86 and ARM-based nodes, and users across the application, users can access this application via the Azure load balancing and the public IP side of things. We have this walkthrough documented on learn.arm.com and many other such sample examples for you to get started. We have customers deploying this in production, and there are really interesting case studies out there, including one that our partner Ampere has published working with Microsoft with Amadeus as a customer. So Amadeus began evaluating their ARM-based processors as part of their partnership with Microsoft, and to achieve a mutual goal of innovating in the travel IT industry. They really needed a sustainable, scalable platform that would lower their cost and provide better performance per rack for their company, and kind of going through the transition of a multi-year journey to migrate from on-prem to Azure-based platforms. Porting to these Ampere CPUs that are ARM-based allowed Amadeus to realize these goals. They kind of achieved 47% better performance per price ratio while maintaining transaction response times. So hopefully that gives you a flavor of the software ecosystem on these instances, what the instance types are, and how you can get started. There are further developer resources for you to leverage, such as developer.arm.com or Works on ARM program, which provides you free access to multiple cloud offerings, including the Azure-based offerings. And we have software repositories at Docker and GitHub to leverage some of these best practices at. There are additional sessions at Ignite that we recommend you take a look at. And here are some of the details, both for online and in-person event. And last but not least, thank you very much. We appreciate your spending time here. We'll also be at Ignite and at the booth. So please feel free to stop by and say hello. Look forward to seeing you and have a great show. Thank you.